This will be for the con assignment, trends in categorical data. Okay, John and Lauren are looking for a good neighborhood to raise their children. They want neighbors who have kids and who are fellow rollerbladers as well. The couple surveys a random sample of residents in a nice-looking neighborhood. The results are shown below. David, Anastasia, and Miles live in the neighborhood. David is focusing on his career and does not have children. Anastasia never rollerbladed. All we know about Miles is that he is very tall. Calculate the following probabilities based on the frequency table below. Round to the nearest hundredth. Okay, probability that David is a rollerblader. Well, they said David is focusing on his career and does not have children. So let's see the probability that David is a rollerblader. Okay, we know that David does not have children or kids. So we're concentrating on this column only. Okay. So they gave us the column totals and they gave us the row totals. So we know David does not have kids. Okay. The probability that David is a rollerblader is going to be 9 out of 18. Okay. But they want a percentage. So 9 over 18 is just 0.5. Okay. Or you can say 0.50. When you move the decimal over 2, that's going to be 50%. So for David being a rollerblader, that's going to be 50%. Okay. And now, probability that Anastasia does not have kids. It says Anastasia has never rollerbladed. So let's go to the not a rollerblader row. Okay, and the probability that Anastasia does not have kids, okay, this row here is for Anastasia because it says she's not a rollerblader. The probability that she does not have kids is going to be 9 out of 12. Okay, 9 out of the total. Okay, 9 over 12 is the same as 3 over 4. Which is 0.75 in terms of a decimal. Move the decimal 2 places, and that's 75%. So enter that in the box. All right, that's just 75%. And then finally, all we know about Miles is that he is very tall. So probability that Miles is a rollerblader? Well, we don't have a column for people that are tall. So we just have to look at the overall thing, the overall chart. Probability that Miles is a rollerblader. Well, here's the rollerblader. Okay, 50 out of 62 are rollerbladers. Okay, in terms of a decimal, that's going to be 0.8064. 80645, right? And converting that to decimal, you move it over 2 places. So that's 80.645%. But what they said was round to the nearest hundredth of a percent. So the nearest hundredth is 2 decimal places. Since this one is 5 or more, we round it up. So that's going to be 80.65. Okay, this number here got rounded up. So in the box, it's 80.65. All right. So you just have to go by the clues that you are given. Okay, again, the write-up isn't really that important. I'll just read it anyway. When a basketball player makes a trip to the free throw line, he takes 2 consecutive shots. It is often wondered whether these 2 shots are independent or dependent. Does the probability of making the second free throw depend on whether a player makes the first free throw? After analyzing data for a basketball star, statisticians determined that his first and second free throws are entirely independent events. The frequency table below shows the data that analysts use to determine this independence. Fill in the missing values. All right. So since the events are independent, first of all, we have the row totals and the column totals. Since the events are independent, the probability here should match the probabilities here as well, here and here. Okay, so let's see. The probability that he makes the second shot is going to be 180 out of 250. Okay, so on the calculator, 180 divided by 250 is going to be 0.72. Okay, so we don't have to worry about anything else because these are all independent events. So the probability of making the second shot is 180 out of 250 or 0.72. Okay. So if these are all independent and the probability of making the second shot is 0.72, it should not matter if he makes the first shot or he misses the first shot because it says the events are independent. All right. So the probability of making the second shot is 0.72. So for making the second shot, it doesn't matter if he makes the first or misses the first. So right here, this is going to be 0.72 or 72% out of 200. Okay? And if I do that on the calculator, I get 144. Okay, so that goes right in here. And again, the probability to make the second shot is 0.72. That's this row. Make the second shot right here. That's going to be 72% or 0.72 out of 50. Okay, and that's going to be a 36. So those are your two answers in the boxes. All right. If you want to check, make sure that they add to the row total. 144 plus 36 equals 180. So that's how I know those are correct. So in those boxes, I'm going to fill in 144. I'm going to fill in 144 and 36. The whole screen moves when I click the box. All right, I'm going to fill those in. And from here, it is easy because we also have the column totals. Okay, so this one here would have to be 200 minus 144. That's going to be a 56. Okay, just to make sure, 144 plus 56 is 200. And this one here has to be 50 minus 36, which is 14. Okay, 36 plus 14 is 50. So here we have 56, and here we have 14. All right, so when you get to these types of problems where it says that the events are independent events, find the probability for the row or column totals and then start filling it in. All right, and then you can just add or subtract at the end. Okay, again, this has a long write-up. I'm not even going to read the write-up. Let's just go to the table and filling the missing values. All right, here's the table, and they gave us the row and column percentages. All right, so let's see. For north-south and Monday, Thursday, we have 115. All right, and let me see. For north-south, the row percentage is 75.16. Okay, so that's north, south, and Monday, Thursday. The row percentage is 75.16. Okay, north, south, Monday, Thursday. So this right here is 75.16% of the whole row. All right, this is the row right here. So 115 equals 75.16% of the whole row. We could say row total. All right. So converting this to decimal, you move it over 2 places. All right. And rewriting, I'm going to write 115 equals 0.7516 times the row total. Okay. Dividing both sides by 0.7516. It cancels over here, and I'll do this on the calculator. 115 divided by 0.7516, and I get 153. Round it off to the nearest whole number. 153 is the row total. That's right here. So this value here is going to be 153 minus 115. Okay, and that's a 38. And now from there, the rest is easy. Okay, this number here is going to be 100 minus 38. So that's going to be 62. And this number here is 236 minus 153. And that's 83. Okay, so just fill in those values. 38, 153. And then 62 and 83. Okay, so I filled those in, and they want us to solve for X as well. So let's see. X is the column percentage for north, south, and Friday, Sunday. All right, let's see the column percentage for north, south, and Friday, Sunday. Okay, column percentage. So it's 38 out of 100, which is 0.38, which is 38%. All right, so the column percentage is 38. Okay, one more. I'm not even going to read the write-up. How many people in this study were both extreme computer users and got 5 to 7 hours sleep? Let's see. How many people in the study?
All right, last problem. Researchers studied the relationship between how long a person uses a computer, how long the person sleeps each night. They were selected at random, classified as minimal, moderate, or extreme. Okay, the relative frequency table summarizes the results. There were 17 people in the study who were both moderate computer users and got 5 to 7 hours sleep. How many people in the study were both extreme computer users and got 5 to 7 hours sleep? Okay, let's fill in the 17 on the chart. It says 17 people were moderate computer users and got 5 to 7 hours sleep. All right, so we want to go to the moderate computer users, which is right here, and got 5 to 7 hours sleep. Okay, so the total is on the bottom. So the moderates that got 5 to 7 hours sleep, this was going to be 17 right here. All right. So that was for 17 people, moderate and 5 to 7 hours sleep. How many people were both extreme computer users and got 5 to 7 hours sleep? Let's see. So we could just do a ratio for this one, okay? Because if you look at the extreme computer users that got 5 to 7 hours sleep, that was 11.7%. See, this is the total percentage right here. And 17 was 10%. So you just do a ratio and proportion, okay? So 10% was 17, and 11.7% is going to be how much? We'll just call that X. All right. So cross multiplying 10 times X equals 17 times 11.7. Okay, and dividing both sides by 10. The 10s cancel, and I will do this on the calculator. Okay, and before I do that, it says round to the nearest whole number, so we're going to cut off the decimal. All right, so I get 19.89. To the nearest whole number, since it's 0.89, we're going to round it up, and that's going to be a 20 right here in the box. So I'll remember 20 for later. Actually, I'll type it in the box right now. Just type 20 in the box, and then we need to do the follow-up. Does the table show evidence of an association between being a minimal computer user and getting 7 or more hours sleep? Choose all answers that apply. Okay, let's see. So as you can see, if you add this and this and this, it's going to add up to 100%. Okay, so like it says, these are total percentages. All right, let's see out of the minimal computer users, how many get 7 or more hours sleep. We have 18.3% out of 35.8%. Okay, so we can just divide those. 18 divided by 35.8. And then for the moderate users, we have 8.3 out of 29.1. And for the extremes, we have 6.7 out of 35.1. Okay, now I can already see the first fraction is going to be the largest. All right, but let me do the calculator work. Okay, this was supposed to be 18.3. Won't make much difference. All right, so I did the fractional calculations. I rounded it to 3 decimal places. All right, and for each of these, if you move the decimal over 2 places, you'll get the percentage. All right, so moving this over, it's going to be 51.1%. Moving this over, it's 28.5%. And moving this over too, that's going to be 19.1%. So as you can see, for the people that use the computer minimally, those people are more likely to get 7 or more hours sleep than the people that use the computer in moderate and extreme. All right. So there's definitely an association, since the minimal computer users are more likely to get 7 or more hours sleep. So let's look at our answers. All right, so we know it's yes. Let me erase my work here. See, just remember this 51.1%, and I'll show you. If you look at answer D, it says yes, because 51.1% of minimal computer users get 7 or more hours, and only 33.3% of all computer users get 7 or more hours. I know the first part is true. Let me just make sure. Only 33.3% of all computer users get 7 or more hours. Here's the 7 or more column. Okay, if you go all the way down to the bottom total, right here, 33.3% get 7 or more hours. So yeah, the minimal guys are more likely to do 7 or more. Okay, so it's definitely yes. So C is no, can't be C. E is no, it can't be E. Let's look at A and B because it says choose all answers. A says 55% of people who get 7 or more hours are minimal computer users. So I think A is true. 55% of people who get 7 or more hours are minimal computer users, but only 35.8% of all people are minimal computer users. Let's see. So if you add up the totals for 7 or more hours, all right, the column percentages, we have 55, 25, and 20, okay? So these three add up to 100%, right? So most of the people that get 7 or more hours are minimal computer users. Now, that could just be because they surveyed more minimal computer users, okay? However, if you look at these three percentages right here, those also add up to 100, okay? And the percentage of minimal computer users they surveyed is 35.8. So since this is greater than this, that means the minimal computer users are still more likely to get 7 or more hours than the other guys. Okay, so I think that one is true as well. So answer A is true. And then finally, answer B, 35.1% of people are extreme computer users and 29.1% are moderate. Okay, yes, those are true statements, but that doesn't show any association between being minimal computers and 7 or more hours sleep. Okay, so answer B didn't have anything to do with 7 or more hours sleep. So A works and D works, all right? And I got the 20 right there. So let's hope this is correct. Okay, got it correct.